In this video, I'd like to talk about the math question of the day for April 6th, 2023. And for this problem, we need to simplify this rational expression where the numerator and denominator are both quadratic polynomials. So to answer a question like this, you will need the tools of Algebra 2 most likely, which is where you will typically see these rational expressions, though you might also learn this in a pre-calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. And the main strategy for simplifying a rational expression like this is to try to factor the numerator and the denominator. So the numerator will be a little bit more difficult to factor because the coefficient on a squared is 5 and it's not 1. If this was 1 and the numbers were different, this would be simpler to factor. But if we look at our denominator, this is a little bit easier to at least start off, since notice that all three of these terms have a factor of 5, or in other words, they are divisible by 5. So we can start by rewriting the numerator. We can come back to that in a moment. And with the denominator, we can factor out that 5 so that we get a squared here minus 2a here and minus 3 here. And you can always check this by just redistributing to make sure that you're doing everything correctly. Now, like I mentioned, if we have a quadratic where the coefficient on a squared, the highest power term, is 1, then it's a little bit simpler to factor. So let's focus on this denominator first, and we'll come back to the numerator. So I'll just rewrite that as 5a squared plus 4a minus 1, and we'll still have this factor of 5. But we can factor this quadratic, or we can try to factor it, into a product of two binomials. And one word of caution is that this doesn't always work. In fact, it works less often than it doesn't work. Since if I just change these numbers a little bit, it stops working. If I make this a 2, or if I make this maybe 12, then it will no longer work. So just minor tweaks in these numbers and it doesn't factor in any easy way. But usually these problems will be crafted so that they are factorable, just so that you can get practice with factoring and dealing with these rational expressions. And we know it's going to factor into two binomials multiplied together. And the first terms in each of these need to be a, since when we remultiply this out using distribution, we'll get a times a, which is a squared, and that will give us our highest power term. But if we look at these terms here, these will be constants. They need to multiply together when redistributing to get this negative 3 here. So we need to think which numbers will multiply to negative 3, and we can make a list of that. If we have negative 3, we can do minus 1 and 3, or 1 and negative 3. And the way to decide which of these factor pairs it is we can ask the question, which of these pairs adds up to the coefficient on this middle term, this a to the first power term? And we can see that 1 and negative 3 will actually add to negative 2. So we put in plus 1 and minus 3. This should be factored. Though, like I mentioned, along the way, you should check your work by just redistributing. And you'll see that you do get back that original quadratic expression. So we've factored our denominator into this product here of 3 different factors. And now we can focus on this numerator. And like I mentioned, it's a little bit trickier. With factoring quadratics where the coefficient on the highest power term is not 1, we will need to use a different method. We can use what's known as the grouping method. So let me make a little bit of room over here, and we can keep working. Let's just look at this separately. 5a squared plus 4a minus 1. And if you want, you can try using guess and check In this case, it's not too bad since one of these will have to be 5a and the other will have to be a. And from there, you can figure out what these constant terms are. But that method tends to be tedious and it's a lot of guesswork. So a more straightforward approach is to use factoring by grouping. And the general idea is that we want to split this middle term up into two terms. We can say plus BA plus CA, where B and C are just the coefficients on A, and when we recombine these, they need to add back to 4. So we need to figure out how to break this up so that we can use factoring by grouping, and the grouping method just pairs two of them together, and we'll pair the other two together, and we can pull out the greatest common factor from each, and if we're left with the same expression, then we can factor that out from both terms, and we will have our fully factored quadratic. And if that's confusing, then it will become clearer as we go through this. Now, how to decide what to break this up into so that it actually works, usually we'll make a little cross here. We know that they have to add to 4, and they have to multiply these two numbers B and C. They have to multiply to the coefficient on the highest power term multiplied by the constant term. So in other words, they have to multiply to 5 times -1, which is -5. So with this information, we're looking for two numbers that add to 4 and multiply to -5. And for that, we can do the number 5 and -1. They add to 4, and when multiplied together, they give us -5. So now we can rewrite this as 5a squared plus 5a minus 1a minus 1. And now we can use the grouping method. We can pair the first two together and the last two together. Now, if this method is confusing, why do they have to multiply to -5 and add to 4? I have completed several videos on this, but I will give you one word of caution. It might be intuitive why they have to add to 4. The coefficients have to recombine to what you started with, or else you change the equation. But this part about multiplying to -5 is not very obvious. Even if you go through a formal proof, I've never seen an explanation of that where you gain a great deal of intuition as to why this is true. It is definitely true, it can be proven, but it's just not that obvious. So usually students will just memorize that they multiply to the coefficient on the highest power term multiplied by the constant term, whatever those are. So something to keep in mind when you do these problems, that this process might not be completely clear. But going back to our problem, once we do break it up into two terms, we can see that we can pair the first two and the second two, and now we can pull out a greatest common factor. From these first terms, we can pull out 5a, and here we're left with an a, and here we're left with +1. You can always check this by just redistributing. And here we can pull out a -1, so that we're left with an a here and a +1 here. And you can always tell that you're doing this correctly if you end up with the same expression in both of these terms here. And we ended up with a +1, and now we can factor out a +1 from each of these. And when we do that, we're left with 5a here and -1 here. So now we have fully factored this quadratic from the numerator. So let's write in what we have. We can work down here a little bit. This numerator, we know this is just a +1 multiplied by 5a minus 1, and we're dividing by 5 multiplied by a +1 multiplied by a minus 3. And we should mention that you should also keep in mind which a values are not possible in this expression. It's just a good habit to notice those things. We can't divide by 0, so a cannot be -1 or 3, because that would lead to a denominator of 0, and division by 0 is just not defined. But with this in mind, now we can make some simplifications. We can notice that we have a factor of a +1 in the numerator and denominator. So those will cancel out, and we will get a fully simplified answer. This rational expression will become 5a minus 1 over 5 multiplied by a minus 3. And if you want, you can redistribute that 5 in the denominator to 5a minus 15. But either way, this would be fully simplified. Now, I should mention one tedious way to check this is that you can pick an a value. Let's say a equals 1, plug it in here, and we would get 5 plus 4 minus 1, which is 8. And in the denominator, we would get 5 minus 10 minus 15, which would be negative 20. And if we end up with the exact same value down here, then we know we did it correctly. We'll plug in a is 1. We would get 5 minus 1, which is 4. And in the denominator, we would get 5 minus 15, which is negative 10. This simplifies to 2 over minus 5. And if we simplify our other fraction here, we divide top and bottom by 4. We get 2 over negative 5. So we got the same value, which means that this expression here is equivalent to this expression here. And we can feel confident that this is, in fact, the right answer.